Today we are going to start finding some values of different angles, like the sine of 60 degrees and the cosine of 30 degrees. Before that, though, we are going to kind of recap a couple things from geometry. First of all, back in geometry, you learned two different types of special right triangles. We have the 45-45-90 triangle, where we have two 45-degree angles and then a right angle. And you learned that there's this relationship between the different side lengths. The two legs of your right triangle are congruent, and the hypotenuse is that leg times the square root of 2. So for another example over here, if you had a 45-45-90 triangle where these legs were 3 each, 3 units, that hypotenuse would be 3 times the square root of 2. And we also have a relationship with 30-60-90 triangles and their side lengths. Okay, the 30-60-90 triangle side lengths. The smallest side is 1. The hypotenuse is twice that. And this long leg is the square root of 3 times the short leg. The square root of 3 times the short leg. And again, if we have a different situation here, if I knew that I have a 30-60-90 triangle, it's not really to scale, but if I have a 30-60-90 where this short leg is 4, the hypotenuse is twice that. The hypotenuse would be 8, and your long leg is the square root of 3 times your short leg. So the square root of 3 times 4, or 4 square root of 3. Hopefully these special right triangles look kind of familiar at least. We are going to use these a lot to help find different values of different angles, even more than just 30 degrees and 60 degrees. So using what we know from geometry, can we find the sine of 60 degrees? Okay, well, let's recap SOH here. Back in geometry, you learned this phrase SOH, which means, if you look at the SO, the sine of an angle equals the opposite over the hypotenuse. The cosine of an angle, abbreviated COS, the cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle equals the opposite over the adjacent lengths. Okay. So O, H, and A all either stand for opposite, hypotenuse, or adjacent. And then S is sine, C is cosine, T is tangent. Again, hopefully this looks familiar from geometry. So knowing that, let's go back and see if we can find the sine of 60 degrees. Well, let's look at our triangle where we have a 60-degree angle. If I look at this one here, sine of an angle is the opposite over the hypotenuse. And in your triangle here, if we look at our 60-degree angle, the opposite side length, what we see across, is the square root of 3. And the hypotenuse, always across from your 90-degree angle, is 2. So the sine of 60 degrees is the square root of 3 over 2. The cosine of 30 degrees, let's do that same process. Cosine, though, cosine is adjacent over hypotenuse. If I look at my 30-60-90 triangle again, cosine of 30, the adjacent side is the side that's right next, and that's the square root of 3. And then the hypotenuse of our triangle is again across from your 90-degree angle. It's 2. Okay, square root of 3 over 2 again. And then the tangent of 45 degrees, let's look at our 45, 45, 90. If I pick this 45-degree angle, it really doesn't matter. Tangent is opposite over adjacent. My opposite side for my angle here across is 1. The adjacent side, right next to my angle, is also 1. So 1 over 1, the tangent of 45 degrees is 1. Okay. So this is just kind of our introduction to our trig functions and a little recap of geometry as we go.